Hey everyone, I'm Alice and welcome to another GRE video. If you're new here, I got a 332 and a 5.5 on my GRE, and I am here to help all of you get the scores of your dream school. Now, before I get started with the content, I want to remind all of you that during all of this weird coronavirus quarantine time, I am doing one-on-one free appointments for all of you for about 30 minutes. I will leave the link to sign up for those in the probably the pinned comment down below. So talk to me about anything, about advice, about planning your study schedule, about writing, about quantitative, about actually looking through an essay that you've written. Anything like that is fair game. Don't forget to like and subscribe as well. And remember that even though I want to try to be as comprehensive as I can on all of my videos, I could definitely miss something. So if you notice anything that I missed, or if you have questions, leave them in the comments down below so I can answer them and other people can see them as well if they have the same question. So today we are talking, as you can see from the title of the video, about the least common multiple. So if you break down the three words here, you can kind of understand what we're looking for. So least obviously means the smallest. Common means things that two numbers have in common. And a multiple is a number that basically is X times as big as your original number. So to give you an example of that, the different multiples of 5 include 5, 10, 15, 20, 25, 30, blah, 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 blah. Basically, it's 5 times any whole number, and you will get all of the different multiples of 5. This kind of question is typically asked when you want to compare two different numbers. So you might get a question like, what is the least common multiple of 5 and 10, for example? Now, if you don't know how to calculate this at all, you can definitely just write down every single multiple of the numbers that you're trying to compare. Now, this can be super time consuming, definitely not the best way to calculate it. If that was the only way to do it, I would not blame you at all for suddenly deciding that grad school is not for you. But in case you really want to stick it out, here's how you do it. You use a technique called prime factorization. Now, if you're unfamiliar with this, I have another video explaining it that I will put in the cards and the description. But as a short summary, prime factorization is basically breaking down a number into all of the prime numbers that make it up. You usually see it as a tree. So for example, I have two numbers here. You can see 24 is a combination of 2 times 2 times 2 times 3, and 30 is a combination of 2 times 3 times 5. So if you're looking for these prime factors, don't forget that you will have access to a very basic plus minus multiply divide calculator on the GRE, and my video will explain how to actually break this down if you're not sure. So notice that all of the factors for 24 and 30 here are prime numbers, which is the key. Now, prime factorization is also used for greatest common factor, which I have another video for. I'll put it in the cards and the description as well if you want to know more. Getting into LCM, or least common multiple, the easiest way to find a multiple that both numbers could have or share is to multiply both of them. This can be effective in some cases, but most of the time you're gonna get an answer that is wildly big, much bigger than it needs to be. If you look at an example, we have here 15 and 20. Now, the least common multiple here is actually 120, and I'll get to how to calculate that. But if you multiply 15 and 20 together, you're actually gonna get 300. So if you don't do this least common multiple technique with prime factorization, you're probably gonna come up with an answer that is way too large. and is not the actual least or the smallest number. It's actually quite simple. What you can do is do your prime factorization trees for both numbers, or however many numbers you have, and put them side by side like this. Now, when you're talking about the least common multiple, the number that you come up with has to contain every value of each number, but you don't have to have overlap. Now, what that means is if you break down 15 and 20 into their component parts, you can see that our end product needs to have 2 2s and a 5 to make up 20, and also 3 and 5 to make up 15. Now you can see the 2, 2, and 3 are unique numbers, so we're gonna have to have all of those in our end LCM product, but you can see that both 15 and 20 have the value 5 in them. Now what this means is that you can actually quote unquote cancel out the 5 and remove one of them when you're talking about the least common multiple. When you do that, you can find that the least common multiple is going to be 2 times 2 times 3 times 5. And if you calculate that out, that equals 120, which is where we got that number. This is confusing. I have a few examples. We can look at this one first, a pretty simple example with 8 and 12. If you break these down into the prime factors, you can see 8 is 2 times 2 times 2, and 12 is 2 times 2 times 3. Now, we need at least 3 2s because of the number 8, but you can see that in 12, you also need 2 2s. Because they overlap with the 2s from the 8, we don't actually need to add them into the least common multiple. Instead, we only have to add that 3 because the 3 from the 12 is the only unique factor that we have here. So if you get the end result, that's 2 times 2 times 2 times 3, that equals 24. Now we have another one that's a little more complicated with 26 and 27. If you break these down into prime numbers, 26 is the combination of 2 and 13. 27 is 3 times 3 times 3. Now you can see there are no overlapping factors or no overlapping numbers in this prime factorization, so you can't cancel anything out. So in order to calculate the least common multiple, you end up just multiplying 26 and 27, and the answer there is 702. Now we have another scenario here with 10 and 100. You can tell here that 100 is a multiple of 10 because 10 times 10 obviously is 100. So you actually don't even have to do prime factorization, but if you wanted to check your work, you can break down the two numbers. 10 is 2 times 5, 100 is 2 times 2 times 5 times 5. So you can see here that the 2 and the 5 repeat once. Because of that, we have an LCM of basically 100. So 2 times 2 times 5 times 5. Now, if we look at one last example, we have 96 and 100. Here, the numbers seem relatively close, but if you break down the prime factorization, 96 ends up being 2 times 2 times 2 times 2 times 2 times 3, and 100 is 2 times 2 times 5 times 5. Now, if you put these side by side, you can see that there are 2 2s that overlap. So basically, here you can get rid of 2 2s, but all the other prime factors we have to leave in the final number. So what that comes out to is 2 to the 5th power times 3 times 5 times 5. If you multiply that together, you get 2400. So you can see even though 96 and 100 are relatively close numbers, that their LCM tends to be very big. So you can't really predict anything based on just looking at the numbers. You really have to use prime factorization and look at those overlapping prime numbers to get your least common multiple. Now, the reason that this works is because you're making sure that your least common multiple can still be divided by your two original numbers, but you're making sure that any of those common prime factors can get deleted so that your final LCM is as small as possible. So that's what's actually happening here. And if you'd like to do a few more practice questions, I have two sets of numbers here. We have 500 and 575 and 24 and 32. Now I'll have the answers at the end of the video if you want to check that out. But I will note also that you can use this technique for any number of numbers. So here in all the examples, we've only been comparing two different numbers, but technically you could compare 3, 4, 5 different numbers and get the least common multiple of that whole set of numbers. That is all I have about least common multiples. I hope everything was very clear. If it wasn't, leave some feedback in the comments down below. I will read all of them and let me know if there's anything else you'd like me to cover. Don't forget, I am offering those free 30-minute meetings and anyone can sign up for those, and don't forget to like and subscribe. These are the answers to the two questions that I had before. Hopefully you got them right. If not, maybe we can talk about them. Thanks so much for watching my video. I hope you have a great day, and I will see you next time. Bye!